Okay, so another way of looking at the distribution is via box plots. They don't display frequency as such. They summarize some of the important characteristics of the distribution. So they're known as box and whisker plots fully because you get a picture like this with a box in the middle, which contains most of the distribution, and then whiskers showing the limits. So how do you interpret this? The middle 50% of all measurements are within the box. So if you imagine a histogram, sort of bell-shaped curve, then you take the middle chunk of that, the middle 50% of all the measurements, all the columns adding up to 50% of all the measurements, and that would go in the middle of the box. So this is, if you like, on its side. The y-axis is showing us the distribution as opposed to the x-axis in the case of the histogram. The median, the middle value, is shown as an orange line in the box. And then the whiskers show the extent of the distribution beyond that, but only up to a certain point. So if you've got quite a narrow distribution, like a very tight histogram, narrow histogram, then you'd find that the whiskers don't go out very far, and so it would look, something like this. But if it turns out that you've got a much wider distribution, maybe a noisier time series or something, then the whiskers will go only up to 1.5 times the length of the box. So they may be less than that, but they might be maximum 1.5. This is a setting in Matplotlib. You can change it if you need to. And then Matplotlib indicates any other values that are outside that 1.5 limit on either side as little circles. You can see one at the top there, and they're referred to as outliers. In this case, that's the maximum value as well, because it's the one at the top. Okay, so let's see some examples with our product data. So here's the code that will do that. So if we look at the code first of all, the single line in bold is the thing that actually creates the box plot. So this is simpler than using histograms. It's much closer to some of the code we've done, say for example, to do line plots, and we just put in the data, the selected data. So I'm picking those 3 columns of the data frame, the 3 high volume columns, and I can set the labels to match those. Just a warning, in old versions of Matplotlib, including the first time I did these slides, you would need to have dot transpose for this to work. That doesn't seem to be the case anymore, but if you get any problems when you're doing this, particularly if it tells you that the length of the labels doesn't match the data, then you may need to update your Matplotlib or Pandas installations. In terms of interpreting the data, I think I'm going to show you the picture if we run the code, which is this one, because obviously it's much bigger. So product F has a much narrower spread. You can see that obviously here. It's showing us, however, and in fact product F has a higher median line, just about. If you look at that, it just about has a higher median line than product A. So product A is the one on the left, product F is the one in the middle. Not sure if you can quite read that. And what else is it showing us? It's showing us, however, that the values for product A are noisier than those for product F. So there's bigger variation. So as we saw in the histograms, there's a wider spread of values, and that sometimes the values for product A actually exceed those for product F. So although in general product A has lower sales than product F, sometimes they exceed. On certain days of the year, they will exceed those for product F. Product L, you can see, has the lowest values of all. It's got some quite extreme outliers as well. So there's one here at 300 for product L. That tells us on one day, or possibly more, but probably one day, there were only 300 sales of product L, whereas the median was more like 400, what's that, about 490, something like that. This orange line here, where my cursor is, but went up to maybe a maximum of 460, something like that. So that's showing you, it's comparing these 3 distributions in quite a nice way for the 3 high volume products. Okay, if we then go on to the next three examples for the other segments of the data, so medium, low, and very low volume products. All you need to do is change the selected list. So in this code, we just change that list for the ones that we've identified as medium, low, and very low. And it makes sense to do that. If you try to put all of these on one plot, they'd kind of fit, but the very low volume and the low volume would just get squashed down to sort of nothing because they're much smaller. Their distribution is much smaller relative to the very large distributions of the high and medium volume sales. And this is showing you some interesting features. So, for example, if you look at the low volume product sales in the middle here, you can see that for this one here, which is product D, I'm not sure you can read that, but I can see that just about, that's product D. There's an awful lot of, in fact, the median value is at 0. So that's telling us that at least half the values were 0. So it does tell us something about those time series that we saw previously, but then the highest value is higher than any of the others. So that's giving us some indication that something's changing in that distribution quite a lot, as we saw when we looked at the time series. In fact, it's 0 for most of the year, or the first half of the year, and then it grows rapidly. You can see that, for example, this one, T, is much noisier than the others. So there's a much wider distribution as compared with the others. And if you look at the, say if you compare that with the very low volume product sales, you'll see actually this is the noisiest data. So they tend to be wider boxes relative to the others, and they tend to have more outliers. And there's an easy explanation for that, which is that because these are very low volume sales, the odd sale here or there can make a big difference. So you would expect that with this very low volume segment, you would expect to see more outliers and more wider distributions as you do. When you get up to the medium volume, they're much more evenly distributed. That doesn't have to be the case, but it's not unexpected. Okay, I think I'm going to finish this video there, and then we'll look at seasonal variation in the next one.